We travel back in time to 4.6 billion years ago to see the moment when our solar system was born. Wow, there's nothing that looks like a star or a planet. So far, there's just a giant cloud of dust. It's called a nebula. These are molecules of hydrogen in heavier elements, along with ice, left there from a previous star. But this cloud isn't dense, so it can't turn into a star or a planet. But then a blast wave comes here, maybe even several. There's a supernova explosion a couple of light years away from our nebula. This is when a giant star burns off its fuel, then collapses under its own weight. At this point, a boom of such force that its light can be seen dozens of light years away. The blast wave from a supernova reaches our nebula like a sea wave. It hits the dust cloud, causing it to shrink and become denser. Then the nebula gained a common center of gravity. It attracted more and more dust particles to itself. This put a lot of pressure on the nebula's core. It started spinning. And the greater the mass of the central cloud, the faster it rotated. The particles inside the core collided faster and more frequently. This raised the temperature of the nebula to several thousand degrees. At this point, a protostar appeared. It was a young and unstable sun. When the temperature in the nebula's core reached millions of degrees, nuclear reactions began there. The cores of light elements like hydrogen and helium hit each other and fused into heavier elements. Let there be light. 4.5 billion years ago, the protostar evolved into a stable sun, but 30% dimmer than we have it now. There's also a giant cloud of dust left behind. This is the remnant of material that didn't take part in the creation of our star. Now you can see the larger objects in this cloud. Heavy elements and dust began to pile up, forming protoplanets. At this stage of our solar system's existence, there were about 100 protoplanets, ranging in size from lunar to Martian. Back then, there was nothing but total chaos. These protoplanets didn't have clear orbits, and they began to collide with each other. Some crashed into a pile of debris, creating massive explosions. Others collided tangentially and simply changed their trajectory. In this cosmic billiards game, the largest protoplanets won. They literally ate the smaller debris and got bigger and bigger. The chaos didn't stop until about 100 million years later. You can see some nearly formed planets: Mercury, Venus, Earth, and Mars. Our home planet now looks more like a lump of lava. The constant bombardment of the surface by various asteroids has heated the planet greatly, but now it has begun to cool down. Everything went quite well until an unknown villain appeared on the horizon. It's Theia. It's a hypothetical planet the size of Mars, formed around the same time as the other planets. And now, it's spiraling toward Earth, ready to hit it. Bam! As a result of the impact, a huge chunk of our planet was knocked out into space. Theia herself was blown to pieces. Its core merged with the core of the Earth, while the rest of the material remained in our planet's orbit. Gradually, the debris from both planets began to collide with each other and merge into a large cosmic body. When the dust settled, the Earth received its satellite, the Moon. Another hypothesis for the formation of the Moon suggests that Theia was much larger than Earth. It only lightly scratched our planet and continued moving without losing its material. And the Moon was formed almost entirely from particles of our planet. As proof of this hypothesis, we have samples of lunar soil delivered by the astronauts of the Apollo mission. It turns out that the lunar soil is very similar in composition to Earth's crust, and it could only have gotten there as a result of some violent event. Gas giants like Jupiter, Saturn, Uranus, and Neptune formed a little later and further from the Sun. These planets are literally balls of gas. There's no solid surface. If you step on Jupiter, you'll fall until you reach its core. These guys couldn't get a solid surface for several reasons. They formed later when other planets took over the metals and silicates. They also all originated beyond the frost line. This is a hypothetical point somewhere beyond the orbit of Mars. The sun doesn't heat the area behind this line enough for water to be in a liquid state. So there was a tremendous amount of ice in the remaining clouds of gas. 3 million years after the birth of the sun, these building materials started to pile up and build mass, becoming proto-Jupiter. Within a couple of million years, this ball of ice could reach a mass about 50 times larger than Earth. And the heavier it got, the more gas from the disk it was able to accumulate. In a short period of time, Jupiter absorbed almost all the material from the disk of gas near it and accumulated about 318 Earth masses. Jupiter had a very strong gravitational field, and it wreaked havoc on all objects in the area between Mars and Jupiter. Protoplanets collided there much more often, causing them to collapse. As a result, we have the asteroid belt. These are fragments unable to reassemble into a full planet because of the intense gravity of the gas giant. Saturn, the next of the 4 gas giants. It's 3 times smaller than Jupiter. It's thought to be so small because it's even farther from the Sun, about 10 Earth-Sun distances. And it began its formation even later when Jupiter left almost nothing of the gas disk. But Saturn got another distinguishing feature: the rings. They're so wide that you could fit 21 Earth planets on them, and they're as thick as a 5-story building. We still don't know how they were formed, but there's 2 main hypotheses. So Saturn has 82 moons discovered so far. There may have been one more, but it was destroyed in a wild collision. The moon was shattered into small fragments that began to orbit the gas giant. These fragments, in turn, collided with each other and shattered again. Gradually, debris the size of a skyscraper turned into small grains of sand. Yep, Saturn's rings are made up of cosmic dust and ice. Then come Uranus and Neptune. They are much smaller, only 14 and 17 Earth masses. It is believed that they couldn't reach the size and weight of Jupiter because of the strong solar wind. It gradually blew the gas disk outside the solar system into interstellar space. So there were much fewer building materials for new planets. When Uranus was formed, it experienced a catastrophic collision with another protoplanet, and probably a very large one. The collision caused Uranus to fall on its side. All planets have their axis of rotation pointing upward, but the axis of Uranus is pointing toward the Sun, so it looks more like a rolling ball. Only it's rotating retrograde. That means it's spinning against its own motion. It's like a car driving forward, but its wheels spinning counterclockwise. Behind the gas giants is the Kuiper Belt. This is the area beyond the orbit of Neptune. This is where the asteroids, dust, and ice were left after the solar system formation. It's similar to the asteroid belt between Mars and Jupiter, but it's about 100 times heavier. Knowing how our solar system was formed, let's see how it might be destroyed. The Sun has a lifespan, just like any other star. Right now, it's about halfway through its life cycle. Every second, the Sun turns 4 million tons of matter into solar radiation. Gradually, it'll run out of fuel and begin to burn heavier elements within it. This will increase the temperature, luminosity, and size of the star. In 1.1 billion years, the Sun will be 11% brighter than it is now. The seas and oceans on Earth will begin to evaporate, and our planet will heat up more and more. In 3.5 billion years, its brightness will be 40% higher than it is now. Conditions on Earth at that point will be similar to what we have on Venus now. Life will be simply impossible. In 7.8 billion years, the Sun will start burning hydrogen in its shell. This will cause it to expand and become a red giant. It'll be about 256 times larger. At that point, the star's outer shell will be exactly where the Earth's orbit is now, but it'll lose its mass. So there's a possibility that our planet will migrate a little further away from it. But it won't matter, because life on Earth won't be able to exist for several billion years already because of the high temperature, and a strong solar wind will simply blow our atmosphere away. Then the thermal pulsations inside the star will tear off the outer shell of the Sun. This shell will turn into a planetary nebula, almost exactly like what we saw at the beginning. And all that will be left of the Sun is a white dwarf, the size of the Earth, which will fade away for a few billion years.
This explosion is the brightest and most powerful in the history of our entire universe, and it was the start of absolutely everything. A Big Bang that happened 13.8 billion years ago. Elementary particles began to spread out in different directions and cool down into matter. This is the building material for the future universe. All the galaxies, black holes, stars, planets, asteroids, and even you and me. Yes, we're all created from the same set of particles that appeared at the Big Bang. A quick jump to 4.6 billion years ago. This is the nebula that's about to become our solar system. It's just a cloud of cosmic dust, rocks, and blocks of ice. Shock waves from supernovas from different directions around this place begin to push matter into a common center, just like sea waves. At one moment, all this matter begins to shrink around a center of gravity into one giant boulder. It attracts more and more other debris to itself. It presses on its own center so hard that nuclear reactions start there. A little more pressure and let there be light. And that's how our sun was born. 4.59 million years ago. This is when the first gas giant planets, Jupiter, Saturn, Uranus, and Neptune, are formed. They're composed entirely of gas and have no solid surface. Some say there was a fifth gas giant, but it was ejected outside the solar system. For another 100 million years, there's a solar nebula, a bright young star in the center, and a disc-shaped pile of gas and dust around it. These are remnants of matter from the original nebula. It's more like a boiling soup. The ingredients swirl around the sun, stirring and colliding with each other. They form the rest of the planets and moons of our solar system. When the dust settles, we can see Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. 4.5 billion years ago, while Earth is still a red-hot lump of rock and lava, Theia appears on the horizon. It's a protoplanet the size of Mars. It's formed close to Earth and is now flying toward it. Theia shatters into pieces and rips out a large chunk of our planet. A lot of debris is left in Earth's orbit and begins to come together. This is how the Moon was born. 4.1 to 3.8 billion years ago. This is the late heavy bombardment period. The remnants of debris that didn't become planets continue to travel through the solar system. They hit the gravitational fields of the freshly born planets and fall on them. Because of this event, we can see so many craters on Mercury and the Moon. Scientists have found the remnants of the oldest microorganisms in the world. They're about 3.8 billion years old. So, they were born around the time when the chaos of ever-falling meteorites ended. The process of evolution began. 3 billion years ago, strong solar winds and frequent meteorite impacts on Mars deprived it of its atmosphere. The atmosphere protected Mars from solar radiation, and now life can't be born there, although some scientists say that Mars was once inhabited. 2.5 billion years ago, an oxygen disaster is happening on Earth. Some organisms evolved to feed on the sun's energy and produce oxygen. Our atmosphere began to fill with it, and this washed away almost all pre-existing life forms. But it did pave the way for new ones. 100 million years ago, one of Saturn's moons was destroyed, either by a collision with a large asteroid or by the planet itself. The moon's debris began rapidly orbiting the planet and colliding with each other and turning into small rocks and dust. Most of this debris consisted of ice, and they remain to circle Saturn to this day. You can see it as rings near the planet. 66 million years ago, Earth suffers the impact of an asteroid the size of Manhattan. The blast waves from the impact can be seen from space. The ash cloud then completely covered the Earth and blocked the sun's rays. As a result of this event, most living organisms, including dinosaurs, ceased to exist. 70,000 years ago, let's look at the edge of the solar system. There's an area of asteroids and blocks of ice, the Oort cloud. And there's a rogue double star system approaching it. It pulls the asteroids out of the Oort cloud and throws them in our direction like a slingshot. Fortunately, the star passed by the solar system, but promised to return. 356 years ago. This is the date of the first discovery of the Great Red Spot on Jupiter. It's the source of strong winds on the planet, with speeds like the fastest supercars. If you compare this spot to the planet Earth, the spot is 30% bigger. Present time. The solar system looks exactly the same now as it did a few billion years ago, but humanity has added some new objects. You can see many artificial satellites and a vast international space station. Even on Mars, there are several rovers we sent there. Now let's look to the future. In the next few decades, Earth will constantly send spaceships to Mars. Every 2 years, when the distance between the planets is shortest, you may see an entire fleet of ships speeding toward the red planet. 100,000 years from now, the rogue star returns to the solar system. It disturbs the Oort cloud again and flies away. In 9 million years, it'll approach a record close distance of 52,000 Earth-Sun distances. 10 million years from now, Mars's moon, Phobos, has been steadily approaching the planet by 6 feet every 100 years. Gravitational interaction will first tear it apart. Some of the debris will fall on the red planet. Others will remain in its orbit in the shape of rings, just like Saturn's. The future of the solar system depends entirely on the Sun. Every 1.1 billion years, its luminosity increases by 10%. This is because, over time, it'll burn more and more hydrogen fuel and get hotter. 1 billion years from now, Earth's temperature will become so high that liquid water will no longer exist. The oceans will evaporate, creating a greenhouse effect that will heat up the Earth even more. The existence of life here will become impossible. At this point, we see an entire fleet of ships flying toward Mars. These were the last inhabitants of Earth. As a result of the Sun's increasing brightness and temperature, its habitable zone, that sweet spot for life in the solar system, has moved farther away from the star. Mars is now much warmer. The ice beneath its soil became liquid and evaporated, creating a greenhouse effect. Now the conditions on Mars are perfect for humans. 3.5 billion years from now, Earth now looks like modern-day Venus. It's filled with lifeless landscapes, with volcanoes and dry riverbeds. 7.7 billion years from now, the Sun's hot core triggers nuclear reactions in the outer shell. As a result, the Sun begins to expand and becomes a red giant. The star will increase 256 times in size. It'll literally swallow the nearby planets, Mercury and Venus. While the Sun is insanely burning fuel, it's losing weight, and its gravity is weakening. This means that it no longer holds all the planets together as much, and their orbits expand slightly. So there's a chance that Earth will remain intact and will now be the first planet near the Sun. Mars has gotten too hot for humans too, and we're making another distant migration, this time to Saturn's satellite, Titan. This is the only place in our solar system where water in liquid form has been proven to exist besides Earth. Conditions here should now be suitable to welcome humanity home. When the Sun uses up a little more than half its fuel, it'll begin to shrink to a size 11 times larger than today. But in another 100 million years, it'll become a red giant again for the last time. After that, in another 30 million years, the star will begin to eject strong solar winds and stellar matter. There will now be a beautiful planetary nebula, which consists of the former outer shell of the Sun. The star will lose most of its weight, which means it'll no longer be able to hold the orbits of the planets. Chaos begins in the solar system. Some planets leave the borders of our world. Others collide with each other. But some of them will be able to stay here, but in a more distant orbit. And in 75,000 years, only a white dwarf the size of the planet Earth will remain in the center of the solar system. The Sun will gradually cool until it fades away completely. If there are still planets left, they will be cold and dark, incapable of supporting any form of life. From its birth to the end, the entire history of the Sun will take about 12.4 billion years.
Our good old solar system is actually a pretty bizarre place, what with all its out-of-this-world phenomena that we humans haven't managed to explain yet. There are rumors that a gigantic, undiscovered planet is hiding behind Neptune. Volcanoes on Pluto spew ice, and a colossal canyon on Mars can accommodate the whole U.S. territory and most of Cleveland. Well, let's figure out if it's true by talking about the most mystifying solar system facts. The solar system is 4.6 billion years old. So old it's a senior solar system. Scientists came to this conclusion after they studied the oldest material they managed to get a hold of. And by that, I mean meteorites, of course. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun, in particular the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and must dodge countless rocks that threaten to damage their spacecraft. Well, sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is next to nothing. You just ruined it. Sorry. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists can't explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet from our sight. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Volcanoes on Earth are as different from those on Pluto as fire and ice, and I mean it. While we have volcanoes spilling lava on our planet, the volcanoes on Pluto spit ice. When frozen water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano gets formed. One of Saturn's moons, Lapidus, has a unique color. It's two-toned. One of its hemispheres is light and the other is eerily dark. Scientists haven't figured out this mystery yet. There's another weird thing about Pluto, or rather, about its atmosphere. First, it rises way higher above the surface of the dwarf planet than, for example, the Earth's atmosphere. What's more, the atmosphere on Pluto has more than 20 layers, and all of them are super cold and very condensed. We live inside the Sun. No, I don't mean that we're inhabitants of the red-hot ball of light approximately 93 million miles away. The thing is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar wind that create the breathtaking phenomenon known as the Northern and Southern Lights. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait! It's not the type of ocean you're thinking about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is a staggering 25,000 miles, which is almost the same as the circumference of the Earth. The Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the sun may have something to do with this unique phenomenon. People came to know about Saturn's beautiful rings in the 1600s, but only recently it became apparent that Saturn isn't the only ringed planet. All the gas giant planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky materials and have no rings whatsoever. Our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses about 100 billion solar systems. And if that's just our galaxy alone, can you imagine how many there are in the whole universe? At any given moment here on Earth, you can stumble across a rock that's arrived from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places on our planet, they came to the shocking conclusion that they have a Martian origin. Since Mercury is the closest planet to the Sun, many people simply assume that it's also the hottest, and that's where they get it wrong, because, in fact, Venus, which is about 30 million miles further from the Sun than Mercury, is way hotter. The thing is that Venus has an incredibly thick atmosphere, which is 100 times denser than the one we have on Earth. On top of that, this atmosphere consists almost entirely of carbon dioxide, also known as a greenhouse gas. These factors make the temperatures on the planet rise to a staggering 875 degrees Fahrenheit, which is hot enough to melt lead. As for Mercury, its maximum temperatures reach only 800 degrees. Jupiter's moon, Io, exists in never-ending chaos due to hundreds of smoking volcanoes on its surface. If you ever visit this place, send me a postcard. Now, you'll see the smoke from these volcanoes billowing up high into Io's atmosphere. The most enormous volcano in the whole solar system, at least that we know of, is on Mars. The size of this monster is almost as great as the state of Arizona, and its height is as big as that of Mount Everest. How did it grow this huge? The answer is simple. There's much less gravity on Mars in comparison with our planet. Even if you're a tiny celestial body, you can still have a moon of your own. Hey, it's not that hard. In 1993, the Galileo probe was traveling past a miniature asteroid that was no bigger than 20 miles across, and discovered the little thing had a 1-mile-wide moon. Since then, astronomers have found tons of moons orbiting minor planets in our solar system. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that's been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. How about you? Do you know any other unusual facts about our solar system that I've missed? Then let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go space traveling just yet. We have over 2,000 cool videos for you to check out. All you have to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of minus 81 degrees Fahrenheit. It drops down to minus 220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the Red Planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the Red Planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you'd see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat.
There's only one star in our solar system, the Sun. And all the planets orbit this star. But there are also systems where a planet orbits 2 suns. For example, Kepler 16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see 2 sunsets and have 2 shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits 3 stars at once. The GW Orionis star system is around 1,300 light-years away from our planet. It's composed of 3 orange rings. They're made of dust and nested inside one another. In the center of this system, you can see 3 stars. 2 of these stars are binary. It means they orbit each other. The 3rd star revolves around them. Scientists have found out that the 3 rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with 2 theories. The first theory says the break in these rings occurred because 3 suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the 3-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarii, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least 2 others. Plenty of star clusters are scattered all over this galaxy. Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, but then they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda Galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our Sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms. And now, an equally strong space hurricane might have come to Earth. It was a swirling mass of air about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced, and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape.
We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did, but that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 16% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 and 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they're made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has 2 of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These 2 space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
Is it possible for a planet to have not 1, not 2, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sun says. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe, so they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like, a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler-22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler-22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler-22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler-22b snuggles up to its star a bit more closely than we do to the Sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler-22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler-22b is about 2.4 Earth size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities. So even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler-22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler-22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler-22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler-22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small. Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
Imagine a planet like Earth, but way heavier. We know that gravity gets stronger as mass increases. That's why giants like Jupiter in our solar system have super strong gravity. Jupiter's gravity is around 81 feet per second squared, which is 2.4 times higher than Earth's. It's so powerful that Jupiter attracts hundreds of asteroids to itself, which, without Jupiter's presence, would have fallen directly to Earth. However, Jupiter is a gas giant, which means it doesn't have a solid surface like Earth does. It's literally a ball of gases and winds with a dense core somewhere deep inside. If you tried to stand on Jupiter, you would sink until you reached it. But what would happen if we were standing on an Earth-like planet with a very strong gravity? First of all, it'd be a lot bigger than our Earth and pretty massive as well. That's a big deal because it would affect its size and how it loses heat. Think of it like this: as things get bigger, they lose heat more slowly, like a big pot of soup simmering on the stove. Now I'm hungry. This means that the surface there will be quite hot. You can imagine a desert or savanna planet. The landscape would be different in general. You'd have shorter mountains and shallow oceans, and the planet would be pretty flat overall. The heavy gravity would make the insides molten, causing lots of geological action and making the surface even flatter. The air on this hefty planet would be super thick because there's a stronger force pulling it down. Breathing would feel like inhaling soup, however weird that sounds. Also, winds and waves would be wild and powerful. And as for flying around, well, it would be tough on high-gravity planets. If we land our spaceship on it, it will be quite a headache to leave later. On the bright side, because the air is thick, the sky would have stunning colors. The sunsets and sunrises would be breathtaking. And when it comes to volcanoes, they'd stay quiet until the pressure reaches epic levels. That means volcanic eruptions would be rare, but crazy when they happen. After landing, of course, you would feel an incredible heaviness. It would feel like you're being squished down. Every step would be a workout, and even lifting things would be a challenge. And forget about jumping high or doing fancy flips. On this planet, your jumps would barely exist. Even breathing itself would be tough for us. So, if we wanted to live there, we'd have to adapt all our sports and games a lot. And climbing one of those short mountains would feel like climbing a never-ending staircase. Buildings would have to be short and sturdy as well, like squat little towers. Tall structures might easily collapse under the gravity's weight. And on a planet like that, even a little tumble could spell disaster. So the inhabitants would be mostly sturdy four-legged creatures, ensuring they stay steady and close to the ground. So any creatures living here would have to be built tough. The best example is the Elcor from Mass Effect. They're a species native to the high-gravity world Dakuna. When it comes to walking around, these creatures would have to choose between stability and saving energy. Fewer legs would be great for saving energy. In that case, they would move like a swinging pendulum, but they wouldn't be super stable. More legs have the opposite effects. These folks would also need beefy lungs to breathe, mighty hearts to pump blood against the gravity, and super dense bones. Their veins might even have muscles, like our arteries. And with so much oxygen around because of the thick atmosphere, these creatures could grow really big. In other words, if we lived on such a planet, we would all look like bodybuilders. The good news is, with all the extra effort, you get to enjoy more tasty food. You'd need the extra calories to keep up with a new lifestyle. That's what it would be like to live on a high-gravity planet. Now, what about the opposite, a planet with super low gravity? Instead of feeling grounded and heavy, you'd feel noticeably light and buoyant. To get a sense of how low gravity might feel, think about the sensation of jumping on a trampoline. When you leap into the air, you experience a brief moment of weightlessness before gravity pulls you back down. Now, imagine if that feeling of weightlessness never really went away. You'd feel incredibly agile, Every step would be a bit like walking on the moon, where you can leap great distances with little effort. One of the biggest differences on such a planet would be the climate and temperatures. Unlike the previous one, this lighter world might not be as effective at trapping heat. This could result in milder and more stable temperatures compared to Earth. Picture a world where every day feels like a pleasant spring day. Seasons might still exist, but the extremes of scorching summers and freezing winters would be much less pronounced. So outdoor activities would be a joy throughout the year. The landscape on a low-gravity planet would be a sight to behold. Mountains would rise to towering heights, their peaks seemingly brushing against the sky. These majestic landforms could reach far above the cloud layers. Valleys and canyons would be deep and sprawling. Breathing there would be a breeze, literally. With a thinner atmosphere, you'd find it much easier to inhale. Winds would be much gentler than on our planet. Storms would still occur, but they wouldn't be anything like what we have on Earth. Life on a low-gravity planet would be different as well. Plants could grow tall and slender, reaching for the skies. Trees might stretch to incredible heights. Animals would be tall and graceful, with long limbs and slender bodies. They'd move with elegance. Wings might be a common feature among them. They also could have developed specialized adaptations, like gas-filled sacs. If we were born on a planet like this, we would also be taller, slender, with quite fragile bones and very thin muscles, like that stretched boy from Charlie and the Chocolate Factory. As you can guess, this planet could be a paradise for sports lovers. Traditional games like basketball, soccer, and volleyball could become incredibly popular here and much more fun. People would be able to jump super high, do backflips in the air, and all sorts of cool moves. And activities like hiking, rock climbing, and even yoga would take on new dimensions. Performing acrobatics would be as natural as walking. And all the hard everyday tasks that require lifting and carrying would feel effortless. Architects and engineers would have a field day designing buildings in this world. They would be able to build very tall and elegant structures reaching the skyline. Our cities would be filled with towering skyscrapers and large windows. Flying and taking off the surface would be much easier. On Earth, launching a spacecraft into orbit requires a tremendous amount of energy. But on a low-gravity planet, escaping the atmosphere would be far less demanding, which means that humans would be able to travel more, and exploring space would become much easier and cheaper. Of course, all that means that transportation would also benefit from the low gravity. Air travel would be incredibly efficient, with aircraft gliding effortlessly through the thin atmosphere. Elevators in tall planets would operate with minimal energy consumption. And in general, since the planet is probably smaller than Earth, traveling there would be much faster. There might be some challenges, though, like fragile bodies and health problems. Also, we would probably get tired faster because of all of the muscle atrophy and other things. And perhaps the ecosystem wouldn't be as diverse as it is on Earth. But still, it looks like living on a low-gravity planet is much better than on a high-gravity one. Moreover, it sounds like it might even be better than Earth. So maybe someday, we'll find a planet that will be like a paradise for humans. Until then, let's take care of our beautiful Earth. In 2021, astronomers announced that they had found between 70 and 170 free-floating planets. Such planets are also called rogue because they don't orbit around any star. And the majority of these huge unattached planets, each approximately as large as Jupiter, dwells in one particular region of the Milky Way galaxy. It's known as the Upper Scorpius OB Stellar Association. Wow, doesn't it sound like the name of some homeowners association? Anyway, this conclusion was made by a team of astronomers that used telescope observations from all over the world and in space. They also looked through 80,000 wide-field images taken over a couple of decades. Scientists have estimated there might be billions or even trillions of rogue planets wandering around our galaxy. If their estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Ooh. This region of the sky is around 420 light-years away from Earth. A lot of amateur astronomers are familiar with it since lots of cool stuff is located there. The most famous targets for astrophotographers include dark nebula, like Barnard 68, Coal Sack, or Pipe Nebula, as well as the colorful region around Rho Ophiuchi. But let's get back to mysterious rogue planets. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. Recently, astronomers have announced one more finding, the tiniest known rogue planet. The mass of this space traveler is somewhere between the masses of Earth and Mars. The term itself, a rogue planet, suggests that such celestial bodies might desert their stars on purpose. They wander off on their own, carving a new path through the Milky Way. But the reality is much more tragic. Rogue planets are usually kicked out of their star systems, doomed to a solitary existence of circling the center of the galaxy on their own. How sad. You see, things get messy when planetary systems, including ours, form. While planets appear from the cosmic dust surrounding a newborn star, they jostle one another around. This gravitational game of pool can easily shove some planets toward the edges of a star system, or eject one or two of them altogether. Then there are also nearby stars that can shove planets around too. Most stars are not born on their own. Clusters of dozens to thousands of stars often appear in space. No wonder that in such a crowded environment, a star with its own set of planets might whisk away a planet or two from another star. After stealing a planet, it can keep it for itself or cast it out into space. At the same time, some free-floating planets might form in a different way, with no parent star to help them. They appear from collapsed clouds of gas and dust, just like stars do. But sadly, they don't manage to put on enough weight to start nuclear reactions, the ones that make stars emit light. These objects are also known as failed stars. Hey, who said they failed? And they resemble planets. Rogue planets are very hard to detect. When astronomers want to find an exoplanet, they look for something blocking the light of its parent star. That's usually the planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because, in this case, there's no parent star. The only way to locate them is to rely on gravity. Now, imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the star's light. This, in turn, makes the star appear brighter than usual. As for the duration of this brightening, it depends on the nature of this moving object. If the brightening lasts a few days, it's a star. If the duration is about a day or so, it's a Jupiter mass object. And if it's just a couple of hours, this object is something that equals the mass of our planet. But the trickiest part is to figure out whether this object is indeed a rogue planet. It's true that stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there still might be a parent star, invisible because of the glare of the luminous star. And astronomers have to wait up to a decade for the luminous star to move a bit to check for a potential parent star. If there's still no parent star in sight, then it's proven. The planet is traveling solo. One thing is clear. Without parent stars to warm them, rogue planets are frozen worlds. Even if ice doesn't go all the way down to their cores, it certainly covers such planets with hard, icy shells. On the bright side, maybe free-floating planets aren't as lonely as we think. They might have moons of their own. They probably take them along when they get pushed out of their cosmic homes. Even more exciting, these exomoons might have liquid water. At least that's what a 2021 study published in the International Journal for Astrobiology claims. Actually, I don't get that magazine, but it sounds fancy. But could a free-roaming world find a new home near a different star? Some experts think it's unlikely. The universe is an incredibly spacious place, and even a large star is hardly able to slow down enough to lasso a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or slowing down. But what if it was a rogue planet? Would it stay with us? Astronomers say it's unlikely. If it happened, they would be thrilled, such a research opportunity. But the rest of us would likely be terrified by the implications of having such a neighbor. At the same time, maybe it wouldn't be such a big problem, considering how big and very empty our solar system is. But even without a rogue planet invading our solar system, the orbits of our planets are going to change one day. In 5 billion years or so, the Sun will start to dim. It'll begin to lose its mass until its gravity is too weak to hold on to the outermost planets of the solar system. Neptune, Uranus, and probably Pluto might turn into rogue planets. They will slowly drift away, unbothered by the cold and mostly unchanged due to their already frozen environments. And yeah, I know the scientists demoted Pluto as a planet years ago, but it's still a planet to me, so sue me. And what about Earth? Oh, our planet will have a different fate, much more tragic. As stars lose mass nearing the end of their lives, they eject gas and dust in all directions. And since our planet is in the way, it'll most likely get enveloped in this scorching stream and vaporize. But calm down, it won't happen for a few more billion years. And who knows where humanity will be at that time. As for now, astronomers hunt rogue planets with enthusiasm. For example, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey to discover more free-floating exoplanets using its powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept, cleverly called Cleopatra. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. To maximize this effect, Cleopatra might hitch a ride on a Mars-bound mission. It's supposed to place it in orbit around the Sun. That's a sufficient distance from Earth, which can help the mission effectively measure the parallax signal and fill in the missing information for astronomers. Now, space missions used to be this big deal, but now they're starting to feel like a walk in the park. But there's a catch. Our bodies aren't exactly built for surviving on other planets. Now, I know what you're thinking. Our bodies will eventually adapt and evolve, right? Well, yeah, evolution is always on the clock. But let's be real here, it's not going to happen overnight. We're not talking about a cool million years for some changes to kick in, and honestly, who's got the time for that? So, how about tweaking our genes just a little bit to make living on other planets easier? Genetic modifications are all about changing an organism's genetic material, like its DNA, to give it some cool new traits or characteristics. Now, picture this. Scientists could totally mess around with our genes to make us more resistant to crazy temperatures. You know, like the temperature fluctuations of the moon, minus 298 degrees Fahrenheit at night to 224 degrees Fahrenheit daytime. Wow. They might even figure out a way to make us super tough against radiation, which is a huge deal in space or on planets with weak atmospheres. We definitely don't want to get fried out there. Oh, and here's another thing they could do. Tackle the effects of low gravity. Spending too much time in low gravity can really mess up our muscles, bones, and even our heart. But if they tweak those genes related to muscle and bone growth, we could become super strong and resistant to all those nasty effects. However, it's not as simple as it might seem. The technology for safe and precise genetic modifications is still in its early stages, so it might even take as much time as it would for our bodies to naturally evolve and adapt to other planets. There are a couple of nice exoplanets where humanity might potentially live. I'm talking about Gliese 667cc, Kepler 442b, Kepler 62e, Kepler 452b, Gliese 837, you name it. In fact, I'm sure you can do a better job of naming than these. Now consider Gliese 667cc. In fact, let's nickname this one Gary for short. Turns out that Gary gets about 90% of the light that Earth does, But instead of regular visible light, this planet mostly gets infrared light. To put it simpler, Gary is rocking only 20% of the visible light that Earth gets. Yep, it's a bit darker over there. So, do we need really warm clothes and night vision goggles to thrive on this planet? Nah, not really. In addition to darkness, Gary is estimated to have a higher mass than Earth, meaning it likely has a stronger gravitational pull. To adapt, humans would need to hit the gym at least twice a day. Translation? Humans would need to develop stronger muscles and bones to withstand the increased gravity. Over generations, natural selection might favor individuals with these adaptations. We still know too little about these exoplanets to move there anytime soon. Hey, how about some planets in our solar system? Let's discover our top picks. This way, we can easily figure out what changes we need to make. So, first things first, let's eliminate the two ice giants in our solar system and their friends. Yep, Neptune, Uranus, and the two gas giants, Saturn and Jupiter. Sorry guys, but terraforming you is just not gonna happen. Even so, we still have 4 super cool candidates right here in our solar system. You all know them well. Venus and Mars, the popular kids on the block. And then we have Jupiter's moon, Callisto, and Saturn's moon, Titan. They might not be as famous, but they've got some serious potential to become Earth 2.0. So, it turns out some of Jupiter's moons are super cool for terraforming. They're packed with water, which is a big plus. But here's the catch. Only Callisto is far enough from Jupiter's radiation belts. You see, on Earth, we get hit with about 0.24 rems of radiation per year. But, for instance, Ganymede, another of Jupiter's moons, gives away a whopping 8 rems per day. Just to make it clear, professional workers here on Earth can have more than 5 rem per year. Callisto is different though. We don't need to tweak our genes as it only gets about 0.01 rems per day, which we humans can totally handle. Now, let's not get too carried away with the idea that life on Callisto is all sunshine and beaches, like in California. Nope, it's more like an icy wonderland out there. So if you ever find yourself on Callisto, make sure to pack your snazziest protective clothing and some high-tech heating systems. Honestly, at this point, we might as well wish for evolution to take us back to our furry animal days. I mean, think about it. Our ancestors were rocking some serious fur game, just like those cool chimps and gorillas. But as time went on and we got all fancy with our evolution, we decided to ditch the fur coat and go for a more minimalist look. Now, why did we lose our fur? That's a question that has puzzled scientists for ages. Darwin thought it was about finding less hairy mates, while others believed it was to keep those pesky lice away. But these days, most researchers think it all comes down to staying cool. Picture this. Our ancestors were strutting their stuff on open dry lands after they learned to walk on 2 legs. Think of a patchy forest or a sunny savanna instead of a lush rainforest. In that kind of environment, overheating was a real threat. So we evolved to have less body hair and more sweat glands to help us cool down by sweating like crazy. Now Titan, the moon of Saturn, is like a treasure chest of resources just waiting to be cracked open. We're talking hydrocarbon reserves that make Earth's look like a kid's play, with petroleum for days. Plus, it's got all sorts of organic compounds like methane, ammonia, and water. And don't forget, its atmosphere is a nitrogen party, just like early Earth's. Here's where it gets really interesting. If Titan's atmosphere is similar to what Earth used to be, we could totally transform it into a modern Earth-like atmosphere. Picture this, giant mirrors in space beaming sunlight onto Titan's surface, heating things up and releasing water vapor. Oxygenated atmosphere coming right up. And to top it off, Titan hangs out within Saturn's magnetosphere, so it's shielded from those pesky solar winds. Now Titan's gravity is about 1/7 that of Earth, which could lead to muscle and bone deterioration over time. To counteract that, our bodies would need to develop stronger muscles and denser bones to withstand the lower gravity. Seems like Earth is the only place where we can't skip gym without gravitational consequences. Now, when it comes to being the hottest planet, Mercury may be the Sun's next-door neighbor, but Venus takes the crown. The temperature there is a scorching 870 degrees Fahrenheit on average. It's like trying to survive in a pot of boiling water or in the fiery depths of Venus itself. I guess the richest people out there would be those selling sunscreens and ice cream. Sorry folks, no amount of evolution can turn us into superhumans who can handle Venus's extreme conditions. The only beings that theoretically could possibly thrive there are tardigrades. These tiny cute little critters that look like caterpillars and have some seriously impressive toughness. They can survive boiling water, the darkest depths of the ocean, and even the freezing airless emptiness of space. In fact, they were part of a scientific study on a spacecraft that unfortunately crashed on the moon. Still, recent research proves that even these guys won't survive on Venus. Now, look at this guy. He's been kicking it on Mars for ages, which explains why he's rocking the wrong shade of self-tan. Turns out all those carrot-loving carotenoids in his diet, like sweet potatoes, bell peppers, tomatoes, and pumpkins, are the aces up his sleeve protecting him against UV rays. The more he munches on those, the more he turns into a walking orange. And let me tell you, his strength? It's all about that Martian gravity, my friend. The gravity there messes with our perception of weight. So if you want to be a boss on Mars, you gotta chow down big time. Like, if you weigh 150 pounds on Earth, it feels like you're carrying no more than 55 pounds on Mars. So overindulging in food can totally help bridge that gap between gravity and weight. Ooh, time to feast like a Martian.